Okay, 7.9 notes, graphing tangent functions, page 26 in your notes. We're going to connect the unit circle to the graph of the tangent function, and we're going to shift tangent graphs. So we are in our unit circle. If we draw a triangle, again, the radius is 1, and then this is our x-coordinate and y-coordinate. This time we're doing the tangent graphs. The tangent is TOA O over A, so our graph is going to be the y over x coordinate. So this is going to look very different than the sine and cosine graphs. So this is our table. Notice we're not starting at 0, which means this graph is definitely going to look different. Instead, we're starting at negative pi over 2, so that's going down 90 degrees. So that is this point right here at 0, negative 1. If you're looking for the tangent ratio, it's TOA O over A. So negative 1 divided by 0 is undefined. So this is definitely going to look different. At negative pi over 4, notice that's the halfway point. So that's going to be over here. I drew it out here to make it easier. Tangent is TOA O over A. So negative 1 divided by 1 is negative 1. And then at 0 radians, you're here. Tangent is TOA O over A, so 0 over 1 is 0. At positive pi over 4, that's up here, that's creating a 45, 45, 90. Tangent is TOA O over A, so 1 over 1 is 1. At pi over 2, that's up here at this point. Tangent is TOA O over A, so 1 over 0 is 1, undefined. You can't divide by 0. 3 pi over 4, that's half a pi, full pi, so it's between half a pi and a full pi, so that's over here, creating a 45 angle. So it's O over A, 1 over negative 1 is negative 1. At pi, you're over here, 0 over negative 1 is 0. 5 pi over 4, that's 1 and a quarter pi, so that's over here. Tangent is TOA O over A, so negative 1 divided by negative 1 is 1. And then we're finally back here. Notice you're going to get undefined. Negative 1 divided by 0 is undefined. So that's our table. If we graph these values here, undefined means it's going to create an asymptote. Then we have negative 1, 0, 1, and then an asymptote. So the graph is going to go through these points and not pass the two asymptotes. Then we have negative 1, 0, 1, and another asymptote. So there's the graph again. So notice it gets a repeating graph. Notice that the domain is going through negative pi over 2 to positive pi over 2 and then repeating in sequences. The range is all real numbers. I don't know why that doesn't look right, but it's all real numbers. Your period, notice it repeats from negative pi over 2 to positive pi over 2. So that's a length of pi, which is different than sine and cosine. Your amplitude is the height from the axes to this point here. So that would be 1. Your asymptotes are at negative pi over 2 and positive pi over 2. So it's this equation. Notice your x-intercept is at 0, 0. And then this graph rotates around the origin 180. So it makes it odd. Shifting, a little bit different this time. Well, we start with the absolute value of A to find the amplitude. If it's negative, it flips on the x-axis. Set this to 0 for your phase shift. But this also will give you your x-intercept. And then you set the inside equal to positive pi over 2 and negative pi over 2. And that will give you your two asymptotes. And then finally, the D is your vertical shift, but there is no vertical shift on the graphs that I have you do. So our amplitude, you take the absolute value of 3, the number in front of tangent, so that's just 3. Notice there's no parentheses, so there is no phase shift. which means your x-intercepts aren't going to shift at all. It's staying at 0, 0, which means your asymptotes aren't moving. They're going to stay at x equals negative pi over 2 and positive pi over 2. So to graph this, you start on your asymptotes, which are on the ends, negative pi over 2, positive pi over 2. Your x-intercept should be at the center of this, so it's going to be at 0, 0 here. You have to scale this, so halfway in between would be negative pi over 4 and positive pi over 4. So remember how the tangent graph looks. If this is our x-intercept, you go left and down to the amplitude, then our x-intercept, then you go right and up to the amplitude. So your graph should look something like this. Make sure you don't pass the asymptotes. For B, absolute value of negative 2 is 2, but there is a flip on the graph over the x-axis. This has no parentheses, so there is no phase shift. Your x-intercept then does not move. It stays at 0, 0. And then your asymptote is going to not move. It's going to stay at x equals negative pi over 2 and positive pi over 2. So on your graph, this is going to be negative pi over 2, positive pi over 2. And your x-intercept is at the center with 0. Scaling, you get negative pi over 4 and positive pi over 4. Remember how the graph looks. You go left and down to the amplitude. However, there is a flip on the x-axis, so it's going to flip up to positive 2. The x-intercept isn't going to move. And then going right, this is going to flip down to negative 2. So it's going to look like this. All right, for part C, the amplitude is the absolute value of the number in front of tangent, so it's 4 with no flip. This does have a parenthesis, so you set it equal to 0, so your phase shift is pi, which means your x-intercept is no longer at 0, 0. Instead, it's at pi, comma 0. Now we have to find the asymptote. So you set the part inside the parentheses to be negative pi over 2 and positive pi over 2, creating two equations to see how this shifts. So to solve for x, we would add the pi over. You need a common denominator, so this is 2 pi over 2 that we're adding to negative pi over 2, which makes a positive pi over 2. That's our first asymptote. Then when we add pi here, 2 pi over 2 plus pi over 2 makes 3 pi over 2. So that is our second asymptote. So on the graph, again, our asymptotes go on first. So the smallest one is on the left side, and then the biggest one is on the right side. And then your phase shift is always at the center. So now we have to scale this. Halfway between half pi and pi is 3 pi over 4. Halfway between pi and 3 pi over 2, if you get a common denominator, that's 2 pi over 2 plus 3 pi over 2, that makes 5 pi over 2, but take half, so it's 5 pi over 4. And then we're going to count by 2's because otherwise this 4 won't fit. So remember, this is your x-intercept. You go left and down to the amplitude, then to the center here, and then right and up to the amplitude. So your graph should look like this. All right, part D, what's the amplitude? Okay, absolute value of the one in front is 1. What is the phase shift? All right, setting the parentheses equal to 0, you get negative pi over 4. What is the x-intercept? Okay, it's negative pi over 4, comma 0. It's this number, comma 0. What are the asymptotes? Okay, you set the inside equal to negative pi over 2 and positive pi over 2. So you should be getting negative 3 pi over 4 and positive pi over 4. So then again, when we graph this, smallest number on the left, biggest asymptote on the right. And then we scale this. So when I add this up, I get negative 2 pi over 4, which reduces to negative pi over 2. Take half. I'm going to get negative pi over 4. Or you could have remembered the phase shift is at the center. Add these up, I get negative 4 pi over 4, which reduces just to negative pi. Take half, it's negative pi over 2. When I add these, I get 0, and half of 0 is 0. So starting at the center, go left and down to the amplitude. At the center, right and up to the amplitude. So there's your graph.